According to IEC 60364-5.54, the standard load for a general-purpose 16-amp receptacle is 3,680 volt-amps. This value represents the maximum continuous load that the receptacle can handle without overheating. When performing load calculations, using known load values for specific receptacles is acceptable. This approach offers a more accurate estimate of the total load demand compared to general assumptions. To calculate the feeder size for a portable office, there are several steps to follow. Firstly, determine the total load demand. Add up the known load values for all receptacles and equipment in the office. If you do not have specific load values, you can use the standard load value of 3,680 volt-amps per receptacle. Secondly, apply a diversity factor. A diversity factor accounts for the fact that all appliances and equipment will not operate simultaneously at their full load. For a portable office, a diversity factor of 0.8 is typical. Thirdly, calculate the feeder load, which is often referred to as FLA, or full load amps. To do this, multiply the total load demand by the diversity factor. Fourthly, select the appropriate feeder size. Refer to the appropriate table in IEC 60364-7.717 to determine the minimum feeder size that will meet the FLA requirement. Here is an example calculation. Suppose you have the following load values in the portable office. Firstly, 5 general-purpose 16-amp receptacles with 3,680 volt-amps each. Secondly, 1 refrigerator at 2,000 volt-amps. And thirdly, 1 computer at 1,500 volt-amps. The total load demand is calculated as follows: 5 multiplied by 3,680 volt-amps plus 2,000 volt-amps plus 1,500 volt-amps, which equals 22,400 volt-amps. Applying the diversity factor of 0.8, the feeder load in FLA is 22,400 volt-amps multiplied by 0.8, which equals 17,920 volt-amps. According to IEC 60,364-7.717, a 3-phase feeder rated at 20 amps would be appropriate for this load. When calculating the total load, consider all devices that will be connected to the electrical system. This includes lighting, heating, ventilation, air conditioning, and any other electrical equipment. If specific load values are not available for certain devices, use the maximum rated power consumption as stated in the device's nameplate. Pay close attention to the units used in the calculations. Ensure all values are converted to the same unit, such as volt-amps, before performing any calculations. The diversity factor can vary depending on the type of load and the expected usage patterns. A diversity factor of 0.8 is a common value for portable offices, but it is important to consult relevant standards and guidelines to determine the appropriate diversity factor for the specific application. The IEC 60364 series of standards provides comprehensive guidance on electrical installations in buildings and other structures. These standards cover various aspects of electrical safety, protection, and design, including load calculations and feeder sizing. IEC 60364-5.54 specifically addresses the selection and erection of electrical equipment, including receptacles and wiring systems. IEC 60364-7.717 provides additional requirements for electrical installations and mobile or transportable units. When selecting the feeder size, consider not only the FLA requirement but also the factors such as voltage drop, conductor ampacity, and protection requirements. Voltage drop should be limited to ensure that the voltage at the load terminals remains within acceptable limits. Conductor ampacity must be sufficient to carry the FLA without overheating. Protection devices, such as circuit breakers or fuses, must be selected to protect the feeder against overloads and short circuits. In addition to the IEC standards, local electrical codes and regulations may also apply. It is important to consult with qualified electrical professionals and authorities to ensure that the electrical installation complies with all applicable requirements. Using the appropriate tools and software can greatly simplify the load calculation process. There are many commercially available software packages that can automate the calculations and provide detailed reports. These tools can also help to ensure accuracy and compliance with relevant standards and regulations. Regularly inspect and maintain the electrical system to ensure its continued safe and reliable operation. This includes checking for loose connections, damaged wiring, and other potential hazards. Promptly address any issues that are identified to prevent electrical faults or accidents. Ensure that all electrical work is performed by qualified and licensed electricians. Improper electrical work can create serious safety hazards and may violate local codes and regulations. Regularly review and update the load calculations as needed to reflect any changes in the electrical load or usage patterns. This will help to ensure that the electrical system remains adequate and safe. Consider future expansion when designing the electrical system. Include spare capacity to accommodate potential increases in the electrical load. This can save time and money in the long run by avoiding the need for costly upgrades later on. Document all load calculations, feeder sizes, and other relevant information. This documentation can be useful for future reference and for troubleshooting purposes. It can also be required for compliance with local codes and regulations. Proper grounding is essential for electrical safety. Ensure that the electrical system is properly grounded to protect against electric shock and to provide a path for fault currents. Use appropriate overcurrent protection devices, such as circuit breakers or fuses, to protect the electrical system against overloads and short circuits. Select the appropriate type and size of overcurrent protection devices based on the feeder size and the expected load current. Install ground fault circuit interrupters, or GFCIs, in areas where there is a risk of electric shock, such as near water sources or in damp locations. GFCIs can quickly detect ground faults and interrupt the circuit to prevent electric shock. Use surge protection devices to protect sensitive electronic equipment from voltage surges caused by lightning or other electrical disturbances. Surge protection devices can help to prevent damage to computers, televisions, and other electronic devices. Clearly label all electrical panels, circuits, and equipment. This will make it easier to identify and troubleshoot electrical problems. It will also help to prevent accidental disconnection of critical circuits. Provide adequate ventilation for electrical equipment to prevent overheating. Overheating can damage electrical equipment and create a fire hazard. Ensure that all electrical enclosures are properly sealed to protect against moisture, dust, and other contaminants. Moisture and dust can damage electrical equipment and create a safety hazard. Use appropriate wiring methods for the specific application. Different wiring methods are required for different environments and applications. Consult with a qualified electrician to determine the appropriate wiring method for the specific installation. Follow all manufacturer's instructions for the installation and operation of electrical equipment. Improper installation or operation can damage electrical equipment and create a safety hazard. Regularly train employees on electrical safety procedures. This will help to prevent electrical accidents and to ensure that employees know how to respond in the event of an electrical emergency. Conduct regular electrical safety audits to identify potential hazards and to ensure that the electrical system is in compliance with all applicable codes and regulations. Address any issues that are identified during the audits promptly to prevent electrical accidents. Stay up to date on the latest electrical codes and regulations. Electrical codes and regulations are constantly evolving, so it is important to stay informed of the latest changes. Consult with qualified electrical professionals to ensure that the electrical system is in compliance with the latest codes and regulations. By following these steps, you can ensure that the electrical system in the portable office is safe, reliable, and compliant with all applicable codes and regulations. Remember to always consult with qualified electrical professionals for any electrical work to ensure that it is performed safely and correctly. The proper calculation of electrical loads and the selection of appropriate feeder sizes are crucial for ensuring the safe and efficient operation of any electrical system. By following the guidelines outlined in the IEC standards and consulting with qualified electrical professionals, you can minimize the risk of electrical hazards and ensure that the electrical system is adequate for the intended use. Remember that electrical safety is paramount, and it is essential to take all necessary precautions to protect people and property from electrical hazards. The information provided here is for general guidance only and should not be considered a substitute for professional electrical advice. Always consult with qualified electrical professionals for any electrical work or to address specific electrical issues. These calculations are essential for compliance and safety.